Everyone, this is Mr. Widmeyer again, and we are going to continue our review of the summer review packet for AP Calculus ABBC by looking at letter C more thoroughly and in depth. Remember that, or keep in mind, right, we already went over some of these in class, excuse me, but I'm going to be going over all of these with you right now in this video. Feel free to jump around to whatever problem you might have a question about too. All right, so here we go. So in this one, no general directions, we just have a setup right here. So if f of x is equal to 1 minus x squared, g of x is equal to 2x plus 1, and m of x is this piecewise function here, where it's equal to the square root of 5 minus 4x for whenever you're trying to evaluate an x value less than 3, or it's equal to the absolute value of x minus 7 whenever you're trying to evaluate an x value greater than or equal to 3. Okay, so we're asked to then find and then evaluate all these function values here. So let's just blow through this real quick. So f of 3. All right, so the letter f there indicates we're using the function f right here. So we're just going to replace that x right here with a 3, right? We're going to replace this x also with this 3. So we just simplify and we'll get negative 8. Okay, g of negative 2. Well, so in this case, right, g indicates that we're going to be using this function right here. And so again, where the x was replaced with the negative 2, we'll replace this x also with the negative 2. And then simplify. And so we get negative 3. Okay. M of negative 11. All right, so again, m indicates that we are using this function right here. And so we will plug in negative 11. Now, in a piecewise function, right, we have pieces. And so we have to determine what piece of the piecewise function we plug that negative 11 into, right? So negative 11, is that less than 3 or is negative 11 greater than or equal to 3? Well, it's less than 3, right? So we're going to plug that negative 11 into this top piece. So it's going to equal, in this case, 5 minus 4 times negative 11, like that. Okay? Negative 4 times negative 11 is positive 44, plus 5 is 49. The square root of 49 is 7. No plus or minus necessary here, okay? Because we're not in an equation setting, we're merely evaluating the expression square root of 49. And so we go to what is known as the primary root, which is 7, the positive root. Okay? All right, next one, number 4. This is called a composition of functions because there's two functions composed together. And we just evaluate them from the inside out, right? Kind of like order of operations. You do the innermost set of parentheses first, then the next outermost set of parentheses, right? So we'll evaluate f of 0 first. So we'll use that right here. So I'm going to continue writing g since we're not evaluating g yet. And f of 0 will be just 1 minus 0 squared, or in other words, it'll be g of, well, 1, right? Because 1 minus 0 squared is 1. And now to evaluate g of 1, we just plug it into our g function here, which is going to be 2 times 1 plus 1, which is just 3. So our final answer is 3. Okay, 5, similar fashion here. We're going to plug 5 into m. And in this case, which part do we plug it into? The top part or the bottom part if we're trying to evaluate an x value of 5? The bottom part, right? So this will be f of the absolute value of 5 minus 7. Try to make those look more like absolute values, not numbers. 5 minus 7 is negative 2, but the absolute value will be positive 2. So we're going to do f of 2, and then plug in 2 to f. So we'll get negative 3, right? Because that's equal to 1 minus 2 squared. So negative 3 is our final answer. Okay, m of negative 1. So that just means we're going to plug it into m, and then whatever the answer is for that, we're going to then plug it into m again. So let's do that. So m of negative 1, well, negative 1 is less than 3, so we're going to plug it into that top one there. So it'll be the square root of 5 minus 4 times negative 1. Okay, like so. And so we get m, and then it'll be 9, so we get 3 there. And then m of 3, ooh, which one do we plug 3 into? The bottom one, because 3 is equal to 3, right? And so we're just going to plug in the bottom one there. So it'll be absolute value of 3 minus 7, which will be positive 4. All right. Now, in number 7, right, we take the x that we had, and we have an x plus h now. Now be careful. This does not equal 1 minus x squared plus h like that. This plus h is not on the outside. It's on the inside with the x. So that means where we have an x, we're going to replace it with x plus h. So here we have an x, so these 1 minus, instead of an x plus h squared. Okay, and now we could multiply this out if we really wanted to here, but technically this is a correct answer. But if we did multiply it out, it would be x squared, it would be negative x squared, oh, whatever. X squared plus 2xh plus h squared. Distribute the minus sign, and then you have the 1. So it'd be just 1 minus x squared minus 2xh minus h squared. And there's not really much else we can do there. So that's pretty much it. Okay, debate about which one of those is more simple, right? Number 8, g of a. So again, we're just plugging in a generic a value here. So this will equal f of 2a plus 1. Because again, we're replacing the x value with an a value there for g. And then for f, we're going to plug 2a plus 1 into f, replacing the x value, so it'll be 1 minus 2a plus 1 squared. Okay, which again, if you want to FOIL this out, you can. So it'll be 1 minus 4a squared plus 4a plus 1, and distribute the minus sign and combine like terms. So we get negative 4a squared minus 4a, and it becomes a minus 1. With this 1 right here, that becomes, they just cancel out, and so this will be the final answer. Okay, if you wanted to factor out a GCF there, you could. Not necessarily, but it's good to see that you can do it. All right, number 9, m of t squared plus 4. Now, t squared plus 4. Now we're going to plug that into m. M's our piecewise function up here. T squared plus 4. What do we know about that? Is it positive? Is it negative? Is it less than 3? Is it greater than or equal to 3? What is it? Well, t squared. If we're talking about real numbers here, right? We didn't indicate that, but in calculus, we're going to assume that we're working with real numbers if we're not otherwise told. So t is a real number. If you square a real number, what do you get? A positive number. And if you add 4 to it, it's still going to be positive. Right, so at least you know it's positive, but we can actually do a little bit better. If you're taking a number and squaring it, then adding 4, which one of these pieces of the piecewise function must it go into? It must go in this bottom piece, right? If you add 4 to t squared, right, the lowest that t squared could be is 0. And you add 4, you're still going to be more than 3. So we're only going to plug it into this bottom piece right here. And so we get absolute value t squared minus 4, t squared plus 4 minus 7. And then combine like terms. So you get absolute value t squared minus 3, like so. And we'll leave it like that. We can't simplify any further than that. All right, number 10 is g minus f. So we're just going to take this function and subtract this function. Okay, so it's just going to literally be 2x plus 1, if you like, put parentheses around it, minus, definitely put parentheses around the f here, so you don't forget to distribute that minus sign. So minus 1 plus x squared, right, is what it becomes. So it becomes x squared plus 2x, and then 1 minus 1 cancels out, and you're left with just the x squared plus 2x. Again, up to you if you want to factor, the GCF out there. Not necessary, though. All right, number 11, we have f of t next to g of t, and when two things are written next to each other in math, that means multiplication, right? So we're just going to do f times g. So it's going to be 1 minus x squared times 2x plus 1. And since we're multiplying two polynomials together, you just want to make sure that each term here multiplies with each term here, okay? Since they're both binomials, you can use FOIL, but remember, FOIL only works when you're multiplying two binomials together. Okay, so 2x plus 1 minus 2x to the third minus x squared. And this is a fine answer, but typically we write in standard form, so I'll make it minus 2x to the third minus x squared plus 2x and then plus 1, like that. Okay, make sure I write that down. That's 2x squared, get 2x plus 1. 2x plus 1 minus 2x cubed minus x squared, yeah. Okay, perfect. Finally, 12. And you may remember this from pre-calculus, okay? This is a very important setup here. It's called a difference quotient. Why do we call it a difference quotient? Because there is subtraction, also known as a difference, and there's a quotient. So difference quotient, very creative, I know. So anyway, we're just going to fill this in. So this can be confusing for students because there's actually kind of two simultaneous substitutions happening here. We have a function we're trying to evaluate, but it's inside of a bigger kind of function going on here. So focus on just this g of x plus h. What does that equal to? Well, here's g of x, right? So g of x plus h then is going to be 2 parentheses x plus h plus 1. Okay, so that is this piece right here. Then for this piece, we're supposed to subtract g of x. G of x is 2x plus 1. So we're just going to subtract the quantity 2x plus 1, and then put this whole thing over h. Okay, now later on in calculus, this will have meaning attached to it, and it's fundamental to have the calculus that we'll be doing. So that's why it's super important that you're okay and comfortable with kind of doing this math right now. Okay, both the substitution and simplification. So distribute and combine like terms. So we'll get 2x plus 2h plus 1 minus 2x minus 1 all over h, and then what cancels? The 2x's go away, the 1's go away, we'll have 2h over h, and we'll say then that's equal to 2. Now, be careful here, right? Those h's cancel, comma, h not equal to 0. Okay, because again, if I put a 0 in for h here, that's going to give me an indeterminate form, 0 over 0. If I put 0 in for h here, well, it's just, there's no h, this is a 2. So be careful. These two things are equal only as long as h is not equal to 0. All right, and again, that's a subtlety you'll see play out over and over again in calculus. So thanks, guys, and we'll see you again for letter D.